Hey everyone, today we're going to be taking a look at a cool concept within TypeScript called discriminated type unions. This concept comes from the broader idea of type narrowing, and that's the process of refining the type of a variable at runtime to be a more specific type. This is useful because it can make your code safer and more precise, and when you're working with union types, it can make your code a lot cleaner. One area where I found this pattern really useful is when I'm defining event types. So for instance, if we're doing event handling in TypeScript with something like mouse clicks and keyboard events, it can allow you to much more easily differentiate between the two in your code. So for example, we'll define a mouse click event. And for each event, we need to define a field that will act as the discriminator. To do so, we're going to define a kind field to indicate the kind of event, and we're going to set it to a click. Beyond that, we can add things specific to the mouse click event. So for instance, we could have a x coordinate, which is a number, and a y coordinate, which is a number. And that's all we'll define to keep the example simple. So we can then define a keyboard event as well. And for that, we want to define a keyboard pressed event. And we have to ensure that we also include the discriminator field. In this case, we previously defined it as kind, so we should do the exact same name here. And we can say key down. Although we want to ensure we have the kind field that matches, we don't need to match the other fields from the mouse click event. So we can define a field specific to the keyboard pressed event, and in our case, we'll just put the actual key that was pressed, which we should expect to be a string. Now we can define a union type, and for that we're just going to call app event, and we're going to set it to be the union of the mouse click event and the keyboard pressed event. We can now define a function that will handle this event, and we can accept an app event as the parameter. Notice that it's the more general union type, so we can't just directly use event.x or event.key, because if we hover over it, we'll see that it does not exist on the type app event, and that's because it doesn't exist on the mouse click event. If you look at the same thing with the x, it'll say the other way around. So the keyboard event doesn't have a property x. So we have to somehow narrow down our type to be the specific one we're expecting. And what is a great way to do that? Well, that's what conditional logic's for. So we can define a switch statement. We'll accept the event.kind as the argument. And if we hover over event.kind, we'll notice that it's either one of click or key down. So we can define the cases for the switch statement. And our first case will be when there's a click. And now inside of this case block, if we console log, we should notice that we are able to output the mouse click event. So we can do mouse click at, and then we'll do the event.x, and then we'll do event.y. And notice here that it is not going to error out on us anymore. It says that this property exists, and if we hover over event, we see that it's been narrowed down to a mouse click event. Same with the y. This is because this click string can only exist on the mouse click event because it's specifically defined there. However, if we were to change this to also be click, then this would error out again because it wouldn't be able to differentiate. It would still be an app event because this kind would exist on two types and it wouldn't be able to discriminate between the two or narrow it down. So we can set the keyboard press event kind back to key down, and then we'll define the case for the other one, which is going to be key down. And then we can console log here, and we should expect to be able to access the key field within the event. We'll just define that the key pressed was event.key, and as you'll see, it even gives us the autocomplete for it. And so that's essentially the idea of what discriminated type unions are. It can also be used with things like numbers. So if we instead had defined these to be like version 1 and version 2 of an API, this would also work. So I'll do case 0 and case 1, and you'll see that this still works without any errors from TypeScript being thrown. Now, what if we had a lot of different events defined throughout our code, and we wanted to ensure in our specific switch block that we thoroughly exhausted all the types and are covering all the edge cases? That's where a switch statement becomes very useful for this idea, because you can use something called the never type and perform exhaustiveness checking. So once you've exhausted all of the types within the app event union type within your switch block, TypeScript will return the never type, And essentially all this type represents is a state that shouldn't exist, and it is assignable to every type, but no type is assignable to it. That is except itself. And this means once you've used up all the types in your union, then never will be the type that remains. To show this, we'll define a default case, and we can define the never type to be an unused variable. That's just going to be the exhaustive check, set it to never, and then we're going to set it to equal the event. And we can notice here that the never type is not erring on us. However, say if we were in the middle of implementing the switch statement and we didn't have the key down case implemented yet. So if we take out this case statement, we'll see that it'll now return an error because we haven't thoroughly covered all of the types within this type union. So it's essentially just a quick safety check to ensure that you're handling all cases within your switch statement. And for instance, if we ever add another type in the future, like a keyboard up event, and we say it's key up, and then we have a key string as well. If we haven't implemented it, even though we add it to our type, it'll now alert us. So this is going to be great if you have your switch statement throughout your code and you need to find specific places where you have to update the blocks accordingly. So I think it's a great idea to use this exhaustiveness check just to ensure that you're covering all edge cases in your code, and it's just a really clean way to handle union types. So we'll just verify this code runs real quick. So we'll just remove this extra type that we added, and then we'll define just a sample event. So we can say const example event and set it to be a app event. We'll do the more general union type, and we'll set it to have a kind of click and the x to 1 and y to 2. And then we can simply pass this to the handle event function. If we pass example event and then run it, we'll see that we get a mouse click at 1, 2 in our log. Now we can change this as well to be the mouse click event more specifically, and if we run it, it'll still work because again, we're using a union type, which will accept either of these types into the event parameter. It's only if we were to change this to a keyboard pressed event when we'd start getting an error because it wouldn't match with the specific type we defined. I'm still learning TypeScript, but coding in it feels a lot better and safer than using JavaScript, and I found this concept pretty interesting when I was using it in one of my recent front-end projects. Anyways, thanks for watching, and I'll see you guys in the next one.